Let's look at how you do the second part. Well, in the second part, we have an ion with a charge on it. And our goal is going to be to fill in all the boxes related to it. Now remember, if it's an atom, it's neutral, and you have equal numbers of those two. So always make sure they're the same when you come down and do the potassium one. They've got to be the same, right? But over here, the electrons are what will change, and we've got to figure out, did it gain or lose an electron? Super important. So remember that if an atom has a negative charge, it means that there are more electrons than protons. I should have abbreviated that. And if an atom has a positive charge, it means it has more protons than electrons. So let's look at this. Fluorine has a -1 charge. Now I know the protons will not change, otherwise it wouldn't be fluorine. So that's got to be the same. But this is telling me if it's -1, do I have more electrons or protons? If you're thinking electrons, you're right. And it means I have one more electron, so therefore it would be 10 electrons. Fluorine was neutral, and as it became fluorine -1, it gained an electron. Pretty cool, right? It's kind of odd that it's -1, but it gained an electron. So that's what I want you to do for each one of these. Look up potassium's number of protons on the periodic table. You know it's got to be the same for electrons when it's an atom. But when it's an ion, I want you to figure out how many electrons it must have.